Welcome to video 5.3b. Use parallel lines to prove that angles are congruent. Okay, so here's example 1. I'll mark it up as we go along. So given that FA is parallel to DE, again for me, if I extend those parallel lines, it helps my brain. So I'll just extend that. And I'll mark them as parallel. Okay. FA is congruent to DE, and AB is congruent to CD. So just this little part here, and just this little part there. And I want to try to get angle F to be congruent to angle E. Okay, so here's some analysis right off the bat. If I want to get this angle congruent to this angle, there's no transversal that goes through with the parallel lines, so I'm not thinking of any transversal action directly. So based on that, I'm thinking of perhaps getting the triangles to be congruent. Okay? So once I get the triangles congruent, then I can get the angles by CP, CTC. All right, so now I'm back in getting triangles congruent mode. Definitely have a side with a side. I'm totally thinking of segment addition over there. So I'll have this side with the left triangle and that side with the right triangle. And now I'm thinking of maybe if I can somehow get that angle to that angle, then I would have some SAS. So right now I'm thinking of using SAS. So really the problem boils down to, can I get that angle to be congruent to that angle? Oh, once again, I've got a parallel line here, a parallel line here, and a transversal here. So whenever you got angles that are kind of connected by parallel lines and a transversal, that's a clue to use these theorems we just discussed. So it's easiest for students to see the parallel lines when they're horizontal. When they're at angle or vertical, students struggle with them a little bit more. So in your mind, try to think, oh, this angle here and this angle here are both on the interior, and they're on alternating sides of this transversal, so they're alternate interior angles, so they are congruent. So I will be able to get them congruent, and then I will be able to prove the triangles by SAS. Now I've got a game plan. Now I start writing down my proof. Okay, I'm going to go in SAS order. So we'll start with step 1. FA is congruent to DE. That was given. And that was the side in SAS. Then I'm going to go for the angle. So I'm going to list this. FA is parallel to DE. That was given. And then from that step, I can get the angle. Okay? I can just use one letter. There's no angle confusion. So I can say angle A is congruent to angle D. If lines parallel, then alternate interior angle congruent. So if parallel, then alt interior angle congruent. So I will be looking for, when I grade your quizzes and tests, that you label the angles correctly. All right, so that's the angle. Then for the side, again, I was given that part, and then I'll do my segment addition. So that would be the AB, congruent to CD. That was given. And then I'm going to add that common segment. If a common segment is added to two congruent segments, then the sums are congruent. So I'm going to say AC is congruent to DB, and I'll allow you to just say segment addition. Now I'm going to get the triangles to be congruent. So triangle, I'll call it FAC. Now once I start that ordering, I've got to use the same ordering over here. F to A, that would be E to D to B. And that would be SAS. And then finally, I can get my angle, first letter to first letter. Angle F, congruent to angle E, by CPCTC. So there you have it, how to use parallel lines to help prove angles congruent.